see. Cool, going live. Pause that. All right, looks good. All right. And we're right here at noon. So welcome everybody. Thank you so much for joining in live today for our June Wednesday webinar. I'm Allison Madison, Program Manager at Wisconsin Saltwise, and always excited to bring in experts in the snow and ice industry to talk about various issues and topics, kind of what's coming up in this industry. So sorry, got multiple screens and things going on as we run this webinar, but very excited to have Jordan Smith with us here today. Jordan is joining from Madison Lake, Minnesota. So that's a little burb just outside of Mankato in southern Minnesota, where Jordan grew up and then started his first snow company as, was it a teenager, Jordan?
I did, yes.
And yeah, so Jordan's got quite the story to share with us, both personal and professional today. And for those of you who are new to our Wednesday webinars, we do really invite you to participate. You can do that in a couple ways. One, you can type any questions or comments that you have into the YouTube chat directly. And then another option is to email me at wisaltwise@gmail.com, and I'll put that into the chat box as well. So you can either type in questions or comments to the chat or email them to me, and then we will take questions from Jordan at the end of his presentation. And just a reminder that today's webinar is going to be archived on YouTube, so you can come back, watch, rewatch, or share it with other folks. So with that, I will turn it over to Jordan.
Thank you very much, and thank you for the nice intro. I'll get my slideshow going here. All right, so as briefly introduced, I am Jordan Smith. Started off in snow and ice as a snow contractor. I'm still a snow contractor to this day, but yes, indeed, back when I was in college, I did landscaping and snow removal as initially just a side hustle to my college career, thinking I'd move on to greater things. But as it turned out, we were pretty good at landscaping and snow removal, and so we're still here today. One of the big things that we did while in our snow business is try to find a way to differentiate ourselves from our local competition. Even though we weren't the biggest, we didn't have the longest tenured experience, didn't have the nicest fleet. And the way that we started to differentiate ourselves is by using liquids and other methods of chloride reduction as a selling point for our clientele. And that's something that we built slow and steady, but good traction with over the years. And over the course of time, we eventually ended up founding a company called VSI, Voigt Smith Innovation, which manufactured liquid de-icing solutions, equipment, as well as implementation strategies. So in parallel with our snow contracting business, we developed this equipment, started another business producing the equipment and selling the equipment on a national level. And we've now recently teamed up with Boss Snowplow, a brand that many people in snow are probably familiar with, in order to even better distribute and support our product on a national and even international level in North America. So kind of a fun story for us is just, this little side concept we had in our small Mankato-based snow operation turned into a international manufacturing business for liquid de-icing solutions. I think the big thing to know with me is what I'm most passionate about is industry improvement and education. I love doing events like this. So any of you that are on this webinar, don't ever hesitate to reach out to me personally, whether through my email, through my LinkedIn, Facebook, however you can find me, or just call our office phone number at VSI. Even though we're teamed up with Boss Snowplow, we're still in our Minnesota office like we were before, same phone number, same Google listing, everything else. So we're pretty easy to find. Love to talk shop with any contractor, any municipal snow worker, state snow worker, anyone who is passionate about snow. I'm all about that. So don't ever hesitate to reach out. So I'll kick it off with a video here to start.
Just a heads up, Jordan, that we don't have any sound from the video.
So obviously, it just kind of made to be sort of an attention grab with the big voice guy and the flashy animations. And obviously, there's more ways to reduce our salt usage than just using liquids. But my focus in this particular presentation will be the ways that we have used liquids to help not only our own snow business, but hundreds of other snow businesses and municipalities reduce their salt impact to the environment. So for any of you that have followed this webinar series, there's many different ways we can make this positive impact. But again, my primary focus in this presentation is going to be one small piece of that, and that is implementing liquids and other best practices to help reduce damage and environmental issues caused by salt and oversalting. So as stated in the video there, kind of a key stat that we'll build around here is there's substantial evidence from multiple different study groups, different consulting groups, and studies done over the years showing how damaging chlorides are to property of any kind. So per ton of salt applied, I know the range is large, $800 to $3,000 is a big range, but regardless of which number you may fall in that range, the main point here is that a ton of salt may cost anywhere between $50 and $150 a ton, depending what market you're in. Even if you're in the most expensive market, the damage caused by that ton of salt is a lot greater than the cost of the salt itself. Now, we obviously understand there's a myriad of liability and other issues that are caused by not salting at all. So how can we solve some of these problems? How can we reduce this amount of salt? How can we create more consistency in the way we're applying it? To help reduce not only that cost of damage, but also the environmental impact caused by that. So from a contractor standpoint, oversalting, despite what your customers may think they want, and you may hear customers say, we want to hear the crunch under our feet, we want to see it. It really does create a bad customer experience because per the images on this slide, we're going to have dead turf, we're going to have dead landscaping, we're going to have rotted doors, we're going to have chlorides leaching up the building. And those are just the things we can see. And where this $800 to $3,000 really comes into play is some of the stuff we can't see. The structural damage to the concrete, the rebar in the concrete, the underground piping, the structural damage that's being done to the buildings themselves. We'll see some of these older clay brick buildings, especially where, they'll have salt leaching on the outside, but on the inside, all of the structure behind that brick is crumbling and falling apart. On parking decks, parking garages, bridges, anything with structural steel, with concrete covering it, we're not even seeing most of the damage that's actually happening under the surface. And that's where the costs really add up. So from a contractor standpoint, the motivation here to reduce chlorides is not just again, for our environment, it's also for the benefit of our customers, and that can also be used as a selling point for our customers. Is we're going to do things a better way. We're going to use best practices to help reduce the use of chlorides on your property, because ultimately it actually benefits you more than anyone else. Again, in many cases, depending on the property damage cost of the chlorides may actually be costing the property owner more than they're paying the contractor to service that property. When you can help them understand the value proposition you bring by helping to reduce that chloride load on their property, that makes you a very valuable resource to that property owner as a contractor. So again, other damages we see from salt beyond outside of the building or inside the building. I know we've had many of our customers, again, in our snow operation, we've been liquids only for 10 years. We continually get comments from new customers on how much cleaner the interiors of their buildings remain in the wintertime, because they're not tracking salt onto their rugs. They're not getting salt chalkiness on their floors. They're not scratching the tile on their floors from any salt being tracked in. And we've even had comments that they've seen a reduction in just random pallet racking feet rusting and leaving rust stains on the floor, just again, because we're not tracking those chlorides into the building. So a lot of positive benefits here, as long as we understand the way to explain this to our customers and show them the things that we can help change. They will quickly get over the idea of needing to have that crunch under their feet by oversalting their property. So the root problem here is contractors need to get parking lots to a safe surface quickly. In order to achieve fast results, salt is often drastically over-applied. So some simple science here. I'm not going to deep dive too long. It's a pretty short webinar, but essentially spreading rock salt and spraying liquid brine are really the same thing. When you spread rock salt on snow and ice, so after the snow has fallen or after you're done plowing, that salt granule creates an endothermic reaction with the snow and ice on the ground, which creates a puddle of brine, salt brine. As that puddle of salt brine spreads, it creates a patch of bare pavement. One of the main reasons that contractors, especially in parking lots, over apply salt is because the spread of that puddle after the endothermic reaction happens is pretty slow. So if the puddle's only going to get that big, that means we need granules of salt very close together in order for those puddle spreads to happen quickly enough to create a bare surface. So scientifically speaking, on a parking lot that at least 90% of the moisture, snow and ice has been removed, it only scientifically takes 160 to 200 pounds of salt per acre in order to get a bare surface, a bare safe surface for our customers. The problem is that in order to get that bare safe surface with that little amount of salt, the granules are going to be too far apart. Those puddles are going to take too long to spread, and now our window of liability is too long, again, because of the speed of the reaction. And that's why contractors typically oversalt, because it's not because we scientifically need that much salt. It's because we need that much salt in order to get the timing to hit with our customer expectations. So the solution here is we can actually use liquid as a alternative post-treatment to granular applications. Now, because we're skipping that phase change, and instead of waiting for the puddle to spread, we're applying the puddle right to the surface, we can apply the scientifically acceptable and necessary amount of salt. And that is, again, that 160 to 200 pounds of salt per acre. Another big benefit to using liquids is that it's substantially easier, typically speaking, to calibrate a liquid sprayer to apply a precise, accurate, and consistent amount of product as it is a salt spreader. I understand and realize that there are more advanced technologies in salting now, where there's salters that have calibration and material monitoring and that kind of thing. In my experience with clients that I've worked with, they do work. They certainly create more consistency than doing nothing at all. But due to the variation in not only gradation of salt, so gradation being the size of the salt granule, but also the moisture content of that salt, it flows differently every single time. And when I say every single time, maybe not literally one day and the next day, but maybe between delivery loads from your vendor, maybe between seasons, and what have you. And what we've typically seen is that when someone calibrates a salter, best practice is to redo it biannually or for sure annually. And what seems to happen in reality, at least in the contractor world, is that it gets calibrated once when they receive it, and that is the only time that it will get calibrated. Now, what this may mean is that at times If the gradation changes one way, maybe that means we're applying less than we planned to, which is maybe okay. When it changes the other way, now we're over applying. Well, the problem is if we're under applying, we're probably not seeing as fast results. We're probably going to do a second application and now we're putting down too much. If we're over applying, then yes, we're over applying. So the problem's not been solved. So again, by using a liquid as a post-treatment alternative, we can eliminate a lot of those X factors and variables. We can now get the fast results our customers need and expect by skipping that phase change, applying the proper scientifically necessary amount of salt to the pavement as a post-treatment. So again, some science here, just not knowing exactly what everyone's experience level on the caller that's watching this recording is. There's a few key things when it comes to the science and uses of liquids. So we already talked about how we can use a liquid as a post-treatment. And even though it's fairly unconventional to talk about using a liquid that way, I always lead off with it because it's kind of the unique differentiator that has put VSI and our snow business on the map, is that we're not just using liquid as a pre-treatment like what most people do. We're using it as a post-treatment as well. We're using it as a full replacement alternative to rock salt. So again, our operation and many of the contractors we work with, they're only using liquids. They've abandoned the use of rock salt, and like my company, don't even own a salt spreader. Not saying that's realistic for every contractor or I know there's some municipal people on this webinar potentially. Maybe it's not as realistic in that setting, but we've been able to prove throughout most markets in North America that you can use liquid as a replacement alternative at least 80% of the time. So there's a pretty strong correlation there to the way you can use liquid. So again, as a post-treatment, we're just skipping that phase change. We're reducing the amount of salt. We're creating more consistency in the amount we're applying. When we're using it as a pre-treatment, which is the more conventional way of using a liquid, I would assume more people on this call have experience using liquid as a pre-treatment. The idea behind that is just to help prevent the bond of the snow and ice with the pavement so that our mechanical removal, our plowing is more effective. So the analogy I like to use, I'm sure you've heard before, is it's like spraying a frying pan before you cook an egg on it. When you pre-treat a parking lot, you're preventing the bond. When you pre-spray a pan, you're preventing the bond of that egg with the pan. It scrapes off more easily. Now the pan's easier to clean. Same thing with the parking lot. Pre-treat it with the liquid, the snow and ice scrapes off more easily. And now there's not much left behind. So either you don't have to salt on the back end or you have to salt less on the back end. Understanding salt brine. So salt brine is literally just salt and water. And we want to mix that salt and water to what's called the eutectic point. So the eutectic point is a 23.3% saturation blend of salt and water, and that has a freeze point of -6. The eutectic point is really important. Number one, because we want to have that lowest possible freeze point to help prevent issues in storage, especially if we're storing outdoors in the Midwest. Obviously, we can get below -6, but it's rare to get below that long enough for the entire tank of liquid to change to that temperature and freeze. The other important reason for that is the eutectic point has the highest energy content in it. It's going to have the molecule space just perfectly enough to have enough energy to be bouncing around and not freeze. But it's not going to have so many molecules that they're packed together and now freeze more easily. So this chart shows the importance of that eutectic point. As we start up here in the top left, the freeze point is 32 degrees, just like water. As we hit that eutectic point, it's -6. You can then see that if we oversaturate our salt brine, it skyrockets back up right back to that 32 degree point, just like water. So for those unfamiliar with brine, you may think if 23.3% salt brine is good, then 25% is probably even better. This chart shows exactly the opposite. In fact, when we hit a full saturation at 26.5%, salt brine freezes at the same temperature as water, which is an issue, especially if our pavement temperature is below 32 degrees. If you ever hear the horror stories of someone applying liquid to a parking lot, turning it to a skating rink, it's more than likely due to either under or oversaturated salt brine that hit a surface that was colder than its freeze point. The brine then freezes to the surface, and yes, you basically sprayed a Zamboni on the parking lot, and that's bad news. So we already talked about the bond prevention. One great thing about eutectic salt brine is its stability and storage. In our snow operation and many of our customers, we're able to store salt brine indefinitely as long as that tank is covered. So we don't have a lot of evaporation happening. I mean, we mix all of our bulk salt into salt brine in the spring so that we're storing it as brine instead of storing it as salt, and it stays stable in solution all the way until the following fall when it's time to use it. One other thing that we don't have time to dive in deeply today on is that in addition to salt brine, we use salt brine additives with our brine. So typically a salt brine additive is comprised of an exothermic chloride, such as magnesium or calcium chloride. So salt is endothermic, meaning it creates a reaction and pulls heat from the surface to create melting. An exothermic reaction is where it's a chloride that actually creates its own heat. So magnesium and calcium chloride have much lower working temperatures than salt brine. So when you mix those chlorides with sodium chloride salt brine, you now have lower working temperatures. Those additives also typically have some other things in them to help reduce corrosion, to help create more stability in the freeze point when and if dilution occurs, and also to help tackify that product to the surface in a pre-treat type setting. So just some high level numbers on what you can expect to potentially save in salt by implementing best practices with liquids in your business or in your government agency. So by using liquid as a pre-treatment, so again, applying the salt brine treatment to the pavement before the snow to help prevent the bond with the pavement so your mechanical removal is more effective, typically will save you between 30 and 35% on your bulk salt. So that's assuming that all you're doing is you're pre-treating before the event, you're using best practices to mechanically scrape the snow, and then on the back end of the event, when you would typically have to put down, let's say 500 pounds of salt, now you have to put down 30 to 35% less because your mechanical removal was more effective. So that's our typical savings right there. In an ideal situation, we've actually seen pre-treatments be effective enough where if you have the proper plow with like a contouring edge system or a floating edge system, and the temperature is a little bit warmer and we haven't had a lot of traffic, we've actually seen instances where you can pre-treat, scrape, and you won't even have to post-treat because the lot scrapes so cleanly. And there's still a little bit of residual chloride there to burn off any potential glaze that may form after plowing, but you don't even have to post-treat with salt or liquid. So that 30 to 35% is just an aggregate average because obviously we're not always going to have that ideal circumstance. Another way to use liquids is if you have salters that are set up with pre-wet systems, or if you have salters you can add a pre-wet system to. Simply pre-wetting that salt with either brine or hot brine with some of the additives I talked about in the previous slide, that can help you reduce your salt usage by 35% in and of itself. The reasons for this is because, again, a lot of this is talking about the same thing. When we spread salt, we're making brine on the ground. The brine is what actually melts and does the work to get bare pavement. By pre-wetting that salt, we are drastically accelerating that activation process of that salt and that endothermic reaction. So that allows us to put down less material because, again, the reason I explained earlier that contractors and people over apply salt is because of the time it takes for that reaction to occur to get a safe surface. When we can get that reaction to happen more quickly, we can put down less product and get the same results. So we typically see up to 35% savings on salt because of that. The one other reason that pre-wetting helps, especially in a setting of doing roadways, is that when the salt hits the surface, instead of bouncing and scattering into the ditches, it tends to stick to the ground where it hits because that salt is wet. And depending on how much pre-wet you're applying, like you can almost make it even like a goo that when it hits the ground, it hits and it sticks and it starts working. So it helps from that standpoint in reducing bouncing and scattering as well. And then the big one, direct application. So you may hear it called post-treating with liquid. You may hear it called direct liquid application, DLA. There's all different terms for it, but basically what that is it's applying, again, the post-treatment, the liquid directly to the snow and ice that remains, whether it's a 1/4 inch dusting of snow that you haven't plowed or didn't need to plow, or whether it is after you plowed and there's snowpack left behind. Direct liquid application is replacing that typical salt application as your method to getting down to bare pavement. And with that method, we've seen up to a 70% reduction in the amount of salt needed. Again, for the very simple science reason of the fact that we're able to apply more consistently, and because we're skipping that phase change and we don't need to over apply to get the results and timing that our customers expect. So just to reiterate a few of these things, again, why should you consider liquids? one of the main things I've talked about here is the time accelerant to safe surfaces. So that's literally the number one differentiator here. Liquid is not some kind of evil magic or something that is totally different than what you're doing now. Again, you're just skipping that phase change so that you can apply the scientifically necessary amount of product instead of over applying to meet customer expectations. Certainly we can recognize some cost savings when it comes to the actual material being applied. So there's obviously the previous slide showed us some of the salt savings we could expect. There's a direct cost of goods sold related to those materials. If we can reduce materials by 30 to 70%, you can take that salt cost line item from your P&L and reduce it by that amount by implementing liquids. Now, in full transparency, it doesn't come free. Obviously, in order to recognize those cost savings, we have to invest in liquid equipment, which is not necessarily inexpensive. Typically speaking, liquid equipment costs double or sometimes more of what comparable salting equipment costs. So it does come at a cost to recognize those savings, and we certainly recognize that. That being said, the savings are typically high enough that over multiple years of use, the ROI is, the return on investment is fairly quick. Rarely do we see, unless you're in a very, very low snow market, rarely do we see people not pay for their equipment in 3 years or less. So yes, it's expensive. The capital expenditure is high, but you can recover it fairly quickly. One other thing that we've really seen with bigger contractors, especially contractors that are working regionally, is that the cost to place a liquid silo tank and containment on a site or on a remote dispatch yard is substantially less expensive than placing a 200 or 300 ton salt bunker with a hoop cover. So we've actually had a number of contractor clients that have claimed that their savings on their storage solution by switching their sites to liquids has been a big enough savings in cost to help pay for the liquid capital expenditure completely. So that's an extreme example and not necessarily applicable to everyone, but it is something worth noting that a liquid silo, I'm not saying they're cheap. I mean, you could spend up to $10,000 on a 10,000 gallon liquid silo. But in order to build a 200 to 300 ton covered salt bin is going to be a lot more than that, plus the logistics of putting it up and taking it down every year, as opposed to simply emptying a tank and hauling it away. Or if you're lucky, you may get clients to allow you to leave the tanks on site. That's what we're able to do in our snow operation. Some other benefits, obviously, we've talked about the efficiency, the effectiveness. Some of the efficiencies that we've seen that I've mentioned are the labor efficiency and the fact that when we send our labor out with a proper spray system that's properly calibrated, they are going to apply that correct amount of product every single time. On our VSI spray systems, I mean, you literally type in, here's how many gallons per acre I want to apply. It adjusts your flow rate based on your speed to apply the right amount of product per acre, regardless of how your operator drives. So even if you have an inexperienced operator that's doing a lot of start and stop, or maybe that's not paying attention, or maybe not driving the right speed, it does not matter with a system like ours, and other manufacturers make calibrated systems like that too, that it will apply the right amount of product almost regardless of the circumstances. The other big thing is effectiveness. So as we all know, one of the limitations of at least white salt is that it doesn't work very well in low temperatures. So in the upper Midwest where we are here, we get down below zero on a frequent basis. White salt does not work. I mean, some people argue it works down to 5 degrees. Some people say it only works to 15. The reality probably lies somewhere in between. But I think we can all agree that white salt does not work below zero. We've successfully used liquids as a post-treatment down to negative 30 degrees Fahrenheit, withstanding puddles in our parking lots. That was not with straight salt brine. Obviously, as we talked about, straight salt brine has a non-diluted freeze point of -6, but we were able to do that by using an 80-20 blend of salt brine and a calcium chloride-based additive. So that effectiveness at lower temperatures is huge. And as we get to those super low temperatures, one benefit is the snow is typically very dry, and that dry snow is very well treated by using a liquid product because the snow doesn't have much moisture in it. So anytime that we're adding something that's mostly water to the surface, the less water that's on the surface, the more effective it's going to be. One other thing that we've noted in our commercial operation is that when we do pre-treat with liquid, our loaders with the plows on them that come into plow after the snow starts, they have a lot more traction under tow, so they're able to push more snow more efficiently. So it's kind of a maybe a not well thought or not well known side benefit is in our early years of using liquids, our operators immediately noticed, like, you know, this site has great traction, the next site I'm sliding all over the place. What's the difference? Well, one site was pre-treated, one was not. We have now implemented a standard practice that we pre-treat all of our sites because it's very inexpensive to do, and the benefits are very great. Yeah, that's kind of one of those side benefits you may not think of otherwise, is that you can gain additional traction with your heavy machinery and trucks after pre-treating a lot. So environmental impacts, obviously that's a lot of what SaltWise is focusing on here. Is the environmental impacts of chlorides are massive. A stat you may or may not have heard is that 1 teaspoon of salt permanently pollutes 5 gallons of water. And again, that's permanent pollution. It's not treatable. It's not fixable. You know, especially when that chloride gets into our wetlands, lakes and streams, that heavier saltwater contamination settles to the bottom, and it stays there. And as that column of polluted water rises, our layer of fresh water gets smaller and smaller, and eventually we have a dead ecosystem there. So this is a permanent deal. It's a big deal, you know, coming from the land of 10,000 lakes here. And I know Wisconsin's big on their appreciation of nature as well. We don't want to lose those resources. Maybe even more importantly, or equally importantly, I should say, obviously, we live on water. Everything we do is based on water. We drink it, we live on it. It goes into every product that we use every single day. We need good, clean water to survive as a human race, obviously. So anything we can do to help prevent polluting that is extremely important. My experience working in the Northeast, what I've seen out there already is that they have a number of areas that are in chloride reduced or chloride restricted areas due to high contamination of their drinking water with chlorides. And again, it is not fixable. That water is permanently polluted. So it's bad news. One other quick stat, in Minnesota, we use about 800,000 tons per year, which is creating permanent pollution of 640 billion gallons of water. So I know those are kind of hard numbers to recognize the scale of, but I think it's always interesting to put it on a grander scale just to realize, like, yeah, 1 teaspoon per 5 gallons sounds bad, but what does that actually equate to? Well, it's 640 billion gallons of fresh water permanently polluted. It's a big deal. Another thing we're seeing, I just mentioned, is regulation. So, you know, we're seeing legislation that's been in place in New Hampshire for liability reduction for a number of years. I think Wisconsin, I'm sure we'll talk about it after here, but Wisconsin is pushing similar legislation. Minnesota is working on similar projects as well. And some of that is, again, to help reduce or change liability rules for contractors so that they don't feel the need to over apply products so much that the customers see and feel that crunch under their feet, just because that's what the customers think they want. And just because in the court of law right now, if someone says, well, I didn't feel a crunch under my feet and then I slipped and fell and broke my arm, now the contractor's liable for that. So we need to change some of those rules so that we can apply the proper amount of salt, not so that we have to apply the amount that people think they need. What I think we're going to see coming in the contractor world in the next 10 years is extremely strict regulation on the use of any kind of chloride in our businesses. So if you are a contractor business owner and you're not thinking about chloride reduction, it'd be better to get ahead of things now than to wait until the government tells you have to. Another big thing is information and education. When we started in liquids in 2010, there was very, very little information out there, especially for contractors. I mean, I remember scouring the internet and just finding nothing besides a few people saying it didn't work and it froze to the parking lot and it was an ice rink and it was a disaster. But I saw our local Minnesota Department of Transportation putting it down on our state highways every single time it snowed. And I always remember thinking, like, man, those state highways really cleared off pretty nice compared to our county roads. And I understand part of that might be level of service, but that's kind of what sparked the idea in my own head. What we've seen the last 5 years, especially again from the contractor standpoint, is just a lot more education and information being out there. Even things like this webinar. I mean, this stuff didn't exist 5 years ago. It just didn't. And if it did, I guess I missed it. But the amount of information and education that's out there now is hugely different than what it was. So the resources are there, and I encourage all of you to use them. We won't need to deep dive into this slide. Just if you are looking at liquid equipment, I think it's important just to look for some key features. I do believe that having a system with that automatic rate control is really important. Again, it's one of the biggest benefits of a liquid system is it's easy to calibrate, easy to apply consistently. But if you don't have that automatic rate control, you're still relying on your operators to put the random one product down. Make sure you have a system, if you're doing parking lots, especially big parking lots, make sure you have a system that can spray more than one pass wide. One frustration I've heard from contractors that started with liquids is they're spraying a single lane and it takes way too long. They say, you know, my spreader spreads 30 feet wide. My salt spreader is so much faster. That's why I use it. There's sprayers out there, including the VSI sprayers that will spray 30 feet wide, no problem. So look for those type of features if those are important for your type of accounts. And then also looking for equipment that can support your sidewalks. Obviously, sidewalks are one of the highest liability areas. Sidewalks are also going to be one of the highest impact areas for your customers. They'll notice immediately when you start using liquids on sidewalks because they're not going to have that tracking in the mess in their building. So those are some key features to look at. Coming up on time here, so I won't spend a lot more time on that, but always happy to answer questions if you ever want to reach out. So I've covered most of this, but how will liquids affect my business? And I apologize to those municipal people here. I'm very much talking from a contractor standpoint because that's where my experience lies. But a lot of these things are applicable to government municipalities as well. But obviously, like for us, it started off as a differentiator from our competition. That's why we started using liquids. Better looking properties, so you won't have that familiar sight of a parking lot that's still white after the snow's gone because of excess salt. I always shake my head driving around Mankato because we have black parking lots, and even after our competition's parking lots are clear of snow, they're still white because of excess salt. As I just mentioned, where's a good place to start as a contractor? Starting with sidewalks is a great way to start. It's very inexpensive. Your CapEx is almost nothing. If you already own snow raiders or Ventrac SSVs or other sidewalk ride-on equipment, it already has brine sprayers built in. So use the systems you already have. You don't need to spend $100,000 to get into liquids. You might be able to spend almost zero. You can mix your own brine in a bucket, or you can buy it from a local supplier if you have one. It's very inexpensive, and using that liquid on sidewalks will make a huge impact for your customers, and it will help you understand the science better and get comfortable with using it on a larger scale. And then the last thing is just driving that demand from property owners. So as a contractor, the value proposition I started with, if you can help them understand that the scope of work that you're charging them for as a contractor on their property is actually cheaper than the damage caused by salt on their property, that's where you bring value to them in a huge way. I always joke with people I'm working with, whether it be my customers in our snow business or people I'm helping with their snow businesses. I say, you can tell them that if they hire you, you'll do the work for free effectively, right? Because you can reduce their chloride load by 70% on their property. And that reduction is going to be equal or greater to what you're quoting them for the work. So it's kind of a hire me for free type deal. And that's an extreme, example of how to approach it. But I think understanding that concept is important and helping educate your customers on that's going to be a driver towards positive change in our industry and for the way that our customers perceive what is best for their property and for their customers. Again, we don't need that crunch under our feet. We only need to use what's scientifically necessary. And that wraps it up for me. Hopefully I didn't go too far over here.
You're great. Thank you, Jordan. And it does look like we have one question that came in the chat. I'm gonna just type my email in there. as well if anybody has questions I want to share via email. But we had a question from Joseph about the source of the figure or statistic that you shared, that a ton of salt will do $800 to $3,000 worth of damage. Could you share that?
Yeah. So there's a organization in Minnesota that used to be called Thornton Consulting. They're now part of Bolton and Mink. So they actually are the ones that wrote the paper. I can probably actually post a link to the study. But they cited a number of different historical, municipal, and other government and university studies for that data, as well as their own research. We also, to sort of do a self-verify on that data, we've worked with our own customers, especially in the government sector, looking at what they've spent on some of their rehabilitation projects, especially on parking ramps. We've seen a incredibly close correlation on the cost of parking ramp rehab projects and the amount of salt that's been applied to those structures over the course of years. So I can specifically cite one that we deep dove on is Reading Parking District in Pennsylvania. They had just completed an X dollar renovation. The parking ramp had been in service for 25 years. We took 50% of the value of that ramp, and we said 50% of the depreciation would have happened regardless, just due to time and age. The other 50% was likely accelerated by the way it got used and treated with salt. And if you take that 50% accelerant factor by using the chlorides in that surface or in that ramp, it came out to almost exactly, I think it was like $100 short of $3,000 per ton of salt applied over that timeline. So they had salt logs for what they had applied over that time. And if you take the renovation cost against the amount of salt applied, it was almost dead on. So that was kind of one example of our self-verification of that data, but I don't have it pulled up right now, but I can certainly provide the link to that study that Thornton provided that data from.
Great. Yeah.
So it comes from 4 or 5 different sources, and maybe you have more color on that too. Right?
Yeah, I can add that I think the primary source that Thornton used was from a 1970s paper. It seems like a lot of the work looking at how much damage salt does to our infrastructure is pretty dated at this point, coming from the 70s, 80s, and I mean, even in the 90s, right? 30 some years ago. And I don't know that people are always even converting that into like $20, $23, but I can put a link to one of the 1970, it looks like 1977 report. And then there's also a summary of a meta-analysis of a lot of research looking at impacts of chlorides on infrastructure that was just done recently, posted I think earlier this year by Sewer Pack, so Southeastern Wisconsin's Regional Planning Commission. So I'll also put a link to that in the chat as well for Joseph and anybody else who's interested. I think we've got some Sewer Pack folks on our webinar today, so shout out to you guys for all of your awesome research savvy and for summarizing that material for folks.
I think one other piece of color to add to that, and again, I'm just trying to speak from areas of personal experience to expand on, I know, studies that may be somewhat dated, but in our experience in our snow operations, one of the value propositions that we offer is that we will guarantee any landscaping or turf damage caused by chloride burn is covered free of charge. So a majority of our competitors are charging for that repair. Like if your grass dies along your sidewalks, or your landscape dies, or your rain garden dies, that's your responsibility. We just did our job and kept your property safe. Well, we guarantee that because we know that by using so much less salt, we don't have anything. We never have grass burned. We never have dead landscaping. We never have destroyed rain gardens because we're not using that much chloride on these properties. So I can't necessarily quantify what that looks like in terms of cost per ton, but like a modern day cost of a engineered rain garden is like $35, $40 a square foot. If you have to completely dig out and redo that thing, I mean, the rain garden alone might put you in the $300 to $400 to $500 per ton range just for the rain garden. That doesn't include concrete, structural rebar, light poles, door frames, sliding doors. I mean, any of that stuff is just extremely expensive. So to me, yes, I think we could use some more color on exactly the source of the data and maybe updating some of that data. But I think just taking a 50,000 foot view of just the obvious things like the cost of the dead turf and landscaping and the rotted door frames, like that's a lot of money just because we're using too much salt.
Yeah, I think one story that you had shared earlier, Jordan, when you were on a call, was a company looking at their doors, like metal door frames in like brick and mortar stores that they had in the northern part of the US where we have snow versus in the southern part. And they were replacing those doors, like, was it twice as often?
Twice as often, yep.
20, I forget what the cost of those was, but
$25,000. Yeah.
Yeah. So yeah, you don't have to go too far, right? Like once you start putting A and B together, you're like, it's pretty eye-opening.
Yep, cool. Exactly.
Well, I'll give a second here if anybody else wants to put a question into the chat. It looks like my chat disconnected for a minute, so I hope I didn't lose anyone's. And I don't see anything yet in the Gmail account. But yeah, otherwise I'd just say thanks to everybody who's here right now. And I mentioned that sewer pack staff Laura Herrick is actually going to give our webinar next month in July, kind of giving a little bit more kind of background on the field work that they did, looking at chloride concentrations throughout the southeastern Wisconsin region. And then, as I mentioned, they've also been looking at impacts to infrastructure and then kind of looking forward kind of policy recommendations. So it'll be coming up next month. In the meantime, if you have any questions for me, I think Jordan would be happy to chat with folks.
Anytime, love to.
Yeah. All right. Well, I think we're good then right now. But thanks so much, Jordan, for joining in today, and enjoy the rest of your week.
Thanks for having me. Appreciate it.
All right. Take care.
See ya.
All right. Well, I think we're good then right now. But thanks so much, Jordan, for joining in today, and enjoy the rest of your week.
Thanks for having me. Appreciate it.
All right. Take care.
See ya.